So we're going to talk about our next notes, the 5.2. It's all about scatter plots. Okay, so a scatter plot is a graph. So it's a graph of plotted points. So it's a graph of plotted points that show a relationship. Oh, I'm off the line. And now off the page. Okay. So it's a graph of plotted points that show a relationship between two sets of data. So between two sets of data. And those are going to be called linear and nonlinear. And we'll get to talking about that in a second. So a scatter plot can either be linear or nonlinear. But then if it's a linear scatter plot, it then has things called a correlation. So a correlation is a relationship. So it's a relationship between two sets of data. Two sets of data. And it's really how it looks, really, is what you're going to go off of. So if it's graphed, you're really going to go off of how it looks. And that can be, there could be a positive correlation, negative, or no correlation. Okay, so scatter plots can either be linear or nonlinear, and then if they're linear, then they have the subset of positive, negative, or no correlation. Does that kind of make sense? Hopefully. So let's look at the types of correlation. So we have 4 different graphs here, right? So you want to look at the way the dots are moving. These dots, as y goes up, so does x, right? Because as soon as we go over, this number is increasing, they're also moving up, right? So this is a positive correlation. Okay, before we say that it's positive, sorry, we have to talk about linear versus nonlinear, right? So, linear, we kind of talked about this before in Unit 4 with functions. Linear, it is a straight line. So linear is a straight line. So do these dots kind of make a straight line? They do. So they're linear. And now because they're linear and as x goes up, so does y, then they're positive correlation. Okay, what about the next one? Does that make a straight line? It does. So this is also linear. And what we notice as y increases, x decreases. So that means it's negative correlation. Okay. You can erase all that stuff. Like, you don't have to draw that if you don't want. So let's look at this next one. Does this make a straight line? Because that's what it needs to do to be linear. No, it's got a curved line. Okay. So this is then non-linear. So then it has no correlation. Okay. So this data here, and the last one, can you make really anything out of that? Do you see a curved line? Do you see a straight line? Do you see any of that? No, right? The points are just all over the place. So this also has no correlation. Okay, so we're going to practice, doing that on the back page. But there are some special circumstances. So there's things called a cluster. A cluster is a group of points. It's a group of points that are very close together. So do you see a cluster? Do you see a bunch of points that are really close together? Hopefully you're saying yes. Right here, right? Yeah, all the other ones, there's a bunch of points, but this has like almost 9 points. So this is a cluster because they're all really close together. An outlier is a point that appears, it's a point that appears to be significantly far. So it's a point that appears to be significantly far from the rest of the data. So an outlier is kind of like a loner. The rest of the data is all together, and then this point's kind of off randomly to the side. Do you see an outlier here on this graph? Hopefully you're saying yes right here, right? All the data kind of makes a straight line here, but not this point. This point is over here. So this is our outlier. Sometimes they might not be as obvious. It might be like here or like here. Okay, so they sometimes might be as obvious as this, but that's definitely far from the data. Okay, so now we've talked about the relationships. Let's practice making a scatter plot. So here we're given a table here. So we have to graph those points, right? So remember, when we have a table, we have an X and a Y. Okay, so our ordered pair is like 0, 1.5. So we're going to want to graph that on this graph. So when we have 0 pizza toppings, a cost of a slice of pizza is $1.50. So at 0, we go up to $1.50. Yeah, there's no exact dot there or an exact line. So we're just going to estimate. So now we've done this one. Go to 1, $2.50. Put a dot there. Go to 2, $3. And put a dot there. Go to 3, $4. 4, $5. Okay. So now we've graphed them all, but that's not what all we need to do. We need to title. So we need to put titles because we want to know, what does this information mean and what does this whole graph mean? Okay. So what was our Y value? What was our Y value in this table? So it's the cost of a slice of pizza. So we're going to write that on the side. So it's the cost of a pizza slice. Because we always have to label our graphs when we're relating information. And now what about X? What did my X represent? Well, it represents the number of pizza toppings. So I'm just going to write that there. And what two things, so I always have a hard time with is coming up with a title for the whole graph. So they give us what X and Y is, so that I felt like was always easy, but we need to put a title for the whole graph. So what two things are we comparing? We're comparing cost and cost of toppings for pizza, right? So your title can be as long or as short as you want, but you're always going to make sure you compare the two things that you're comparing. So you're comparing cost and the number of toppings. Okay, so that's where we got the title from. Okay, let's go to the next page. And we want to determine the relationship. So the first four are just graphs. So you want to look at those and determine if they're linear or nonlinear, if they have a positive, negative, or no correlation. Okay, so I want you to pause right now and do those four. Okay, do A, B, C, or D. Look at those graphs and see what kind of relationship they have. All right, so let's look at these then. So the first one, A, it kind of makes a curvy line with those data points, right? So that's why it's non-linear. And because it's non-linear, it has no correlation, right? B kind of has a downward slope, and we could make a straight line out of that. So it's linear with a negative correlation. Letter C kind of makes a positive slope. It's increasing both ways. So it's linear with a positive correlation. And then D, we kind of really can't make any sense of those points, right? So it's no correlation. Okay, so there's one other thing that we need to do. So sometimes it won't be given as a graph. Sometimes it'll be given as the two things it's comparing, right? So for E, it's the number of hours playing video games and the grade point average of the student. So we need to figure out, is there a correlation there? Well, what do you think? So, okay, let's say the number of hours of playing video games, let's say as that increases, what do you think happens to the student's grade point average? Or what would you expect to happen? So if you're not doing homework because you're playing too many video games, what do you think would happen to your grade? Well, it would go down, right? So as one thing increases, the other goes down. It's going to be a negative correlation. Okay. Let's look at F. So the cost of various types of sneakers. So as the cost of sneakers goes up, do you think the size of the sneakers makes it go up? No, right? There's really no, we don't know that, right? So if it's like, you have to special order it, then obviously yes, but it's various types of brands. So it's not just like one brand. And we're saying if you wear size 4 and I wear size 7, my shoe should be more expensive. But that's not really how it works. Like the basic sizes, they all cost the same, right? So there's no correlation here. No correlation. All right, so I want you to try G and H on your own, and we'll go over those in class next time I see you, okay? So try G and H on your own.